What's up, everybody? Today we're going to be going over the Windows Fundamentals 3 room from TryHackMe. So we'll go ahead and jump right in and get started. So task number 1 is just the introduction, and this one's really mostly just setting the stage for what the room is going to cover. If you already did Windows Fundamentals 1 and 2, then you kind of know the deal here. Those first 2 rooms were more about just getting comfortable with Windows itself, where stuff is, how to move around, system utilities, things like that. This room kind of shifts more into the security side of Windows. So built-in protections, updates, Defender stuff, firewall, BitLocker, all that. They do give you the machine details here if you want to RDP into it. You can do that if you want. I'm just using the browser-based machine because honestly, it's quicker, and for a room like this, it's totally fine. So go ahead and hit Start Machine. Give it a second to boot up because sometimes these things are a little slow. And once that's up, you're pretty much ready to go. If you want to use your own setup over VPN, you can do that too. But for most people, just opening the VM in the browser is the easiest way to get through this one without adding extra steps you really don't need. So I used a little time skip for you so we don't wait for the machine to load. Alright, so now we're on to task number 2, Windows Update. And this is one of those things where even people who are not into tech at all have probably dealt with it, because Windows is always trying to update something. Basically, Windows Update is Microsoft's built-in service for pushing out security fixes, patches, bug fixes, and feature updates. And from a security standpoint, this matters a lot, because when new vulnerabilities get discovered, the fix often shows up through Windows Update. So yeah, it can be annoying sometimes, but it is also one of the main ways Windows stays protected. They also mention Patch Tuesday, which is worth knowing. That's usually the second Tuesday of each month, and it's when Microsoft commonly releases a big batch of updates. That does not mean they only patch things on that day, though. If something serious comes up, they can push an update earlier. Patch Tuesday is just the regular update cycle you'll hear mentioned a lot. To get there, the room shows the normal settings route, which is fine, but honestly, the fastest way in these Windows rooms is usually just to search for it directly. So open the Start menu, type Windows Update, and open Windows Update settings. Once you're in there, a couple things may stand out. First, you might see a message saying the settings are managed by an organization. Most people on a normal home PC will not see that. So if your own machine looks different, that's completely normal. That message usually shows up more on work machines or lab VMS. You'll also notice there are no new updates available in this VM, and that's because this machine does not have internet access to go check Microsoft's update servers. So if you're wondering why it is not pulling anything new, that's the reason. On a normal connected machine, you'd usually click Check for Updates, let Windows search, then install what it finds and restart if needed. And yeah, like the room points out, people love delaying updates until Windows eventually kind of forces the issue. That's because some of these updates are important enough that Microsoft really wants them installed, especially the security ones. For the actual question here, though, we do not care about checking for new updates. We care about the update history, because the room asks about the 2 definition updates that were already installed on the attached VM and what date they were installed. So this is where you want to click View Update History. That's the part people sometimes miss because they stay on the main update page too long. Once you open the history, you should see the 2 definition updates listed there along with the install date. Let's just write it in to the answer box, and we are going to task 3, just like that. Let's check out task number 3, Windows Security. And this is kind of the main hub for a lot of the protection features the room is going to keep pointing back to. So Windows Security is basically Microsoft's central place for managing the built-in security tools on the system. Instead of hunting around for everything one by one, a lot of the important protection settings are grouped here in one dashboard. The easy way to get to it is just open Settings and click Windows Security, or search for it directly from the Start menu. Once you open it on the VM, you'll see a few main protection areas. The big ones they care about here are virus and threat protection, firewall and network protection, app and browser control, and device security. The main thing to understand is the status icons, because that is basically the whole clue for this task. If you see a green check mark, that usually means everything looks okay. Yellow means Windows has a recommendation or something you should probably review, and red means something needs attention right now. So for this task, you do not need to go digging deeply into each section yet. You're really just looking at the dashboard and spotting which area is showing the warning. One quick thing the room mentions, and it does matter a little, is that this VM is running Windows Server 2019, so it may not look exactly like a normal Windows 10 or Windows 11 home machine. That is completely normal, so if your screen looks a little different from the screenshot, don't let that throw you off. Once you're in the Windows Security dashboard, just look through those protection areas and find the one with the red status indicator, the one that needs immediate attention. And in this case, that area is virus and threat protection. So that's the correct answer for task 3. Open Windows Security, understand what the color indicators mean, spot the section marked in red, and you're done. Task 4. All right, now we're in virus and threat protection, and this is the section that was throwing the warning in the last task. So now we're basically just zooming in on that. When you open it up, it's split into two main parts: current threats and virus and threat protection settings. Current threats is more about what's going on right now, like scan options, threat history, things that were detected, quarantined, or allowed. Then the settings section is more about how Microsoft Defender is behaving in the background. Up top, they go over the scan options, which are pretty straightforward. You've got Quick Scan, Full Scan, and Custom Scan. Quick Scan checks the common places malware usually likes to hide. Full Scan goes through basically everything, so it takes longer. And Custom Scan lets you point Defender at a specific file or folder. You'll also see threat history, which is useful because it gives you a record of what was found before, what got quarantined, and what got allowed. And that allowed threats part is definitely something you want to be careful with, because if Windows flags something as dangerous and you manually allow it anyway, you're basically telling the system to trust it. So unless you know exactly what you're doing, that is usually not something you want to touch. Once you get down into the settings, this is where some of the more important protection features show up. One big one is real-time protection. That's the feature actively trying to catch malware while it is being opened, run, or changed, not just later during a scan. So on a normal machine, this is something you would usually want turned on. You'll also see cloud-delivered protection, which helps Defender use Microsoft's cloud data to react faster to new threats, and automatic sample submission, which can send suspicious files or samples to Microsoft for analysis so they can confirm whether something is malicious and improve protection for other systems too. Then there's controlled folder access, and this is the one that matters a lot for the room. This feature helps protect files, folders, and certain memory areas from unauthorized changes by untrusted or malicious apps. In plain English, this is one of the protections aimed at ransomware, because ransomware loves to get in and start encrypting or changing files. That's why the room ties it into ransomware protection. If the question asks what can help protect your files against ransomware, the answer is controlled folder access. One detail the room points out, and it's worth not getting confused by it, is that real-time protection is turned off in the attached VM. That sounds bad at first, but in this lab it is expected. The VM does not have internet access. It is meant to be a controlled environment, and sometimes settings like that are changed to keep the lab running more smoothly. On a real machine, though, you would generally want real-time protection enabled. You may also notice exclusions, which lets you tell Defender not to scan certain files, folders, or processes. Just like allowed threats, that is another area you do not want to mess with casually, because you are basically telling Windows to ignore something it might otherwise inspect. The room also mentions that you can run an on-demand scan on a specific file or folder by right-clicking it and choosing Scan with Microsoft Defender. That is just a handy extra detail, especially if you only want to check one item instead of scanning the whole system. For the task question, though, the important part is the warning message. The thing Windows is specifically notifying you to turn back on is real-time protection. You can see that directly in the alert saying it is off, and that the device may be vulnerable because of it. So that's really task 4. Open virus and threat protection. Understand the difference between current threats and the settings area. know what controlled folder access does for ransomware protection, and recognize that the specific feature turned off in the VM is real-time protection. Firewall and network protection. And this one is pretty straightforward once you slow down and look at what the three profiles actually mean. The room defines a firewall as the thing that controls what is and is not allowed through ports, kind of like a security guard checking what gets in and out. And that's really the easiest way to think about it here. So if we click into firewall and network protection on the VM, right up top you're going to see the three big profiles they care about: domain network, private network, and public network. And the point of this task is not really to go mess with advanced rules or anything like that. It's more just understanding when each profile applies. The room says domain is for systems that can authenticate to a domain controller, private is for user-designated home or private networks, and public is the default profile used for public places like coffee shops, airports, and stuff like that. So yeah, if you click into one of these profiles, you'll see the options they mention. Things like turning the firewall on or off and blocking all incoming connections. You can poke around and look at it, that's fine. But honestly, this is one of those areas where, unless you really know what you're doing, you should mostly leave it alone. The room flat out warns you to keep Windows Defender Firewall enabled unless you're 100% sure about what you're changing. They also mention allowing an app through the firewall, and that basically means creating an exception. So instead of turning the firewall off completely, you're saying this specific app is allowed to communicate through it. That can be useful for things like games, remote tools, or local services, but don't just allow random apps because Windows asks nicely. Only allow it if you actually trust the app and understand why it needs network access. Then there's the advanced settings panel, and that's where things get more detailed. This is where you can create inbound and outbound rules, control ports, protocols, profiles, and all that more granular firewall behavior. Very powerful, but also, very easy to mess up if you start clicking around without a reason. So for now, just understand the difference. Allowing an app is like making one specific exception, while advanced settings is where you manage the actual rule system behind the firewall. We're not going deep into that here because that's not what the question is asking, but it's good to know what those buttons are for. They do give a little tip that if you ever want to open the Windows Defender Firewall directly, you can do it with wf.msc, which is kind of nice to know. Not something you need every day, but it is, quicker than clicking around once you know it. Now down to the actual question. It asks if you were connected to airport Wi-Fi, what most likely would be the active firewall profile. And since paid attention to me in the room, you know that public networks include Wi-Fi hotspots at coffee shops and airports, so the answer is going to be public network. You little over-caffeinated fire ant-like creature. So go ahead and submit that. And with that, we're done with task number 5. App and browser control. And this one is more about awareness. So this is one of those tasks where you mostly just want to understand what these settings are doing and not get too lost in the weeds. So if we click into App and Browser Control, this section is where you can change the settings for Microsoft Defender Smart Screen. And Smart Screen is basically there to help protect you against phishing sites, malware websites, sketchy applications, and the downloading of potentially malicious files. So in normal person terms, it's one of those layers in Windows that tries to stop you before you click on or run something dumb off the internet. Not a bad thing to have. You'll usually see the status set to warn, and they mention you can change that to block or just turn it completely off. Warn is kind of what it sounds like. It throws the warning and lets you know, hey, this thing might not be safe. Block is obviously more aggressive, and off is, well, yeah, off. Usually, not what you want unless you have a really specific reason. Then under that, you've got Check Apps and Files. And this is just Smart Screen checking unrecognized apps and files from the web. So if you download some random executable that doesn't have a good reputation, Windows can step in and say, hold on a second before you run that. That's the whole idea. They also mention exploit protection, and this part is a bit more advanced. It's built into Windows 10 and, in this case, Windows Server 2019 as well, and it helps protect the device against attacks. This is where you start getting into lower level mitigation stuff, the kind of settings that can help make certain exploit techniques harder to pull off. We're not going to go line by line through every option because, honestly, you do not need that right now. And the room itself is basically just introducing you to the fact that this exists. And they give the same kind of warning they've been giving in a few of these sections, which is basically, unless you are 100% sure what you're doing, leave the default settings alone. That's really the right takeaway here. This is security stuff, but not the kind where tweaking everything manually makes you smart. Sometimes the smart move is just not breaking the defaults. So yeah, go ahead and read through that section, click around a little bit so you know where it lives, and since the question is just read the above, you can just mark that complete. And with that, we're done with task number 6. Let's go with task 7, device security. And this is one of those sections where for most people, you're probably never really going to come in here and start changing stuff. But it is still worth knowing what's in here, because these are some of the lower level protections built into Windows. The room even kind of says that, like, yeah, you'll probably never change these settings, but for completion's sake, we're going to cover them briefly. So if we click into device security, you'll see stuff like core isolation, and under that, memory integrity. And what memory integrity is doing is helping prevent attacks from inserting malicious code into high security processes. So basically, if malware wants to mess around with protected parts of memory, Windows is trying to make that more difficult. That ties in a little bit with the last section too, because a lot of these protections kind of layer on top of each other. And again, same warning as before, unless you are 100% sure what you are doing, leave the default settings alone. That's kind of a recurring theme in this room, honestly. Windows has a lot of security defaults that are there for a reason, and for the most part, you are not going to improve your life by randomly flipping them around. Then they show another feature under Security Processor, and this is where the question is actually coming from. They use another machine in the screenshots for this part, which is worth noticing because if you're clicking around in the attached VM and it's not lining up perfectly, that's why. And yeah, sometimes the lab machine is just slow too, which is always fun. But the important thing they want you to look at here is, the Trusted Platform Module, the TPM. So, what is a TPM? Per Microsoft, it's designed to provide hardware-based security-related functions. In normal language, it's basically a dedicated security chip in the computer. It handles cryptographic operations, and it has physical protections built in to make tampering harder. So instead of all of that sensitive security work living purely in normal software, some of it is anchored in actual hardware, which is obviously better from a protection standpoint. You do not need to overanswer this one, though. The room just asks, what is the TPM? And the answer is right there in the name. It stands for Trusted Platform Module. So submit that. That is the correct answer. And with that, we're done with task number 7. Task 8. Let's check out now BitLocker. And this is another one where the room is mostly trying to make sure you know what the feature is and what it's for, not trying to turn you into some full disk encryption expert in 5 minutes. BitLocker is basically Windows Drive encryption. Per Microsoft, it's a data protection feature built into the operating system that helps address the risk of data theft or exposure, especially on lost, stolen, or improperly decommissioned computers. So yeah, if somebody gets the machine, the goal is that they still don't just get the data for free. They also point out that BitLocker provides the most protection when it's used with the TPM, which makes sense after the last task because that TPM is the hardware-backed security piece helping with all the crypto-related stuff. So those two features kind of go together. You do not need to go super deep into how the encryption process works here, though. Just understand that BitLocker is there to protect the contents of the drive, and TPM helps make that stronger. Now, one little thing that can waste your time on this task, they let you know BitLocker is not included in the attached VM. So if you're clicking around trying to find the exact same screen and it's not really there, that's why. This is more of a read the documentation task than a click through the VM task. If you were on a machine that had it, you could usually just search BitLocker or manage BitLocker and get there. But, for the room question, the answer is coming from the text itself. And the exact question here is basically asking what the removable drive contains on systems without TPM, or said another way, what the user has to insert when the computer doesn't have TPM 1.2 or later. The key phrase they want is that a startup key has to be stored on a removable drive. So yeah, not just a USB in the vague sense, even though that is the removable drive part. The more correct answer is a USB startup key. So go ahead and submit that. That's the correct answer for task number 8. And with that, we're done here. Before we move on to task 9, just a quick note. Depending on when you're watching this, I may already have a full cybersecurity course linked in the description. It contains the complete learning path I built over 3 to 4 years, the same material that helped me land my first cybersecurity job. So you can skip a lot of the confusion around what to learn, when to learn it, and how deep to go. Task 9, Volume Shadow Copy Service. And this is one of those Windows features that's actually really useful, but from a security perspective, you also kind of have to understand its limits, because it sounds better on paper than it always is when malware gets involved. The room defines Volume Shadow Copy Service, or VSS, as the thing that coordinates the actions needed to create a consistent shadow copy, basically a snapshot or point-in-time copy of data that's going to be backed up. So in normal brief, this is Windows keeping a snapshot of stuff so you can potentially roll back, restore, or recover if something goes wrong. And they let you know those shadow copies are stored in the System Volume Information folder on each drive that has protection enabled. You usually don't need to go digging around in there manually, but it is good to know where they live conceptually because that comes up in both admin stuff and security discussions. Now, if VSS is enabled, which means system protection is turned on, there are a few things you can do from advanced system settings. You can create a restore point, perform system restore, configure restore settings, or delete restore points. So yeah, this is tied into a lot of the Windows recovery type stuff people have at least heard of, even if they've never really used it much. And if you want to click through it in the VM, they do give you a little path for that. You can basically get into the drive options and configure shadow copies from there. Not super complicated, although with these lab machines, sometimes stuff opens slowly and kind of fights you for no reason, which is always a nice touch. But the point is just to see that this feature is there and it can be managed. Now, the important security note here, and honestly, this is the part worth remembering, is that malware writers know about shadow copies. So ransomware will very often look for these and delete them specifically so you can't recover your files that way. That means VSS is helpful, but it is absolutely not something you should trust as your whole recovery strategy. If ransomware wipes the shadow copies too, you're out of luck unless you have an offline or off-site backup somewhere else. That's really the big practical takeaway from this task. So down to the actual question, it just asks, what is VSS? And this one is nice and simple. VSS stands for Volume Shadow Copy Service. So submit that, that's the correct answer. And with that, we're done with task number 9. All right, last task, the conclusion. We've covered the main Windows security features: updates, Windows security, firewall profiles, app protection, device security, BitLocker, and VSS. Main takeaway? Windows already has a lot of built-in protection. You just need to know where it is and what it's for. The room also mentions Microsoft Docs and living off the land if you want to go deeper. If you followed along in the VM, terminate the machine. That's Windows Fundamentals 3 done. I believe the next one will be about Active Directory, so that can be fun. See you in the next one, you medium-sized Naruto filler episode.